Hello students, in the previous video we learned Newton's third law of motion. For every action there is an equal and opposite reaction. Now let's see some real life application of this law. Our first example is walking. When we walk, we push the ground backward with our feet. This is the action force. In return, the ground pushes us forward with an equal and opposite force. This is the reaction force. Because of this reaction force, we move forward. So, whenever we walk, Newton's third law is working. Now, let's understand how a rocket moves. A rocket engine throws hot gases downward at a high speed. This is the action. According to Newton's third law, these gases push the rocket upward with an equal and opposite force. This is the reaction. Because of this reaction force, the rocket raises into space. That is why rocket can move even where there is no air. Let's take another example. When a bullet is fired from a gun, the gun pushes the bullet forwards. This is the action force. At the same time, the bullet exerts an equal and opposite force on the gun. This is the reaction force. As a result, the gun moves slightly backward. This backward movement of the gun is called recoil. Look at the situation. A scenario is standing on a board and jumps forward. While jumping, he pushes the board backward. This is the action. The board then pushes the sailor forward with an equal and opposite force. This is the reaction. As a result, the sailor moves forward and the boat moves backward again. Newton's third law is clearly visible. Now students, after understanding Newton's third law and its application, let's move to another important concept related to motion. To understand this concept, we need to learn about Galileo's experiment on a smooth inclined plane. This experiment helped scientists understand why objects continue moving and lead to the idea of inertia, which we will study next. Let's see how Galileo experimented it. Now students, let's understand Galileo's experiment on a smooth inclined plane. Galileo used two smooth slopes and a ball. First, he released the ball from the top of one slope. As the ball moved downward, its speed increases because gravity pulled it down. When the ball reaches the second slope, it started moving upward. Now its speed gradually decreases and it's climbed up the slope. Galileo observed that the ball always tried to reach almost the same height from which it was released. Next, he made the second slope less steep. The ball still tried to reach the same height, but now it had to travel a longer distance. Finally, Galileo imaged that if the second slope became completely horizontal and there was no friction, the ball would never stop. It would keep moving with the same speed forever. From this experiment, Galileo conducted that an object continues in its state of rest or uniform motion unless an external force acts on it. This property of an object to resist any change in its state is called inertia. So Galileo experiment laid the fundamental for Newton's first law of motion, which is also known as the law of inertia. Now students, let's solve one numerical based on Newton's second law of motion. A stone of mass 1 kg is thrown on a frozen lake with an initial velocity of 20 meters per second. After traveling 50 meters, it comes to rest. We have to find the force of friction acting between the stone and the ice. First, let's write the given values. Mass m is equal to 1 kg, initial velocity u is equal to 20 meters per second, final velocity v is equal to 0 meters per second. Distance s is equal to 50 meters. Since the stone finally stops friction in acting opposite to its motion and slowing it down, to find the friction force, we first calculate acceleration using equation of motion, substituting the values. 0 square is equal to 20 square plus 2 into a into 50. 0 is equal to 400 plus 100 multiplied by a minus 400 is equal to 100 a is equal to minus 4 meter per second square. The negative sign shows that the acceleration is opposite to the direction of motion. This is called retardation or deacceleration. Now, using second law, F is equal to 1 into minus 4, F is equal to minus 4 Newton. The negative sign only tell us the direction of force, therefore the magnitude of the friction force is 4 Newton acting opposite to the motion of the stone. So our final answer is force of friction is equal to 4 Newton opposite to the direction of motion. This numerical shows how Newton's second law help us calculate force when acceleration is known.